Yes, ma'am.
In the first slide, you had the MSCs coming out of the bone marrow. That was the mistaken assumption about the stroma?
Well, we started working on bone marrow. It's a long story, but there's a history in orthopedics going back to Aristotle, stating that there's some very positive aspect of bone marrow on repair of bone. I can explain that in several ways, but because we were looking for these stem cells, we thought the perfect place would be bone marrow, and I had a long association with orthopedics in a variety of contexts, and so we started with bone marrow and purified MSCs and passaged them in culture. But then, of course, I was appalled to the core that somebody published a paper saying they could get MSCs from fat. I mean, I can't think of anything more disgusting that for somebody who works on marrow to say that there was an equivalent cell in fat. And so I says that has to be completely wrong. So that turned out to be completely correct, as is every other tissue. But those cells that we get from marrow are highly heterogeneous. So as I showed in that poster, there's at least 2 different MSCs. There's another MSC that actually is already in the osteogenic lineage. So there's probably 5 different phenotypes of MSCs that you get from bone marrow. Our mistake also in culture, after we passaged them a couple times to expand the number, they were more or less uniform when we sorted them on a cell sorter. So we said, as did many other people, that it was a homogeneous preparation. Not so much. So the original characteristics of the cells, which is the interesting thing, depends on the site in which they came from. And they would sense that microenvironment, and they would both respond in a very similar way. And so that's one of the facts about all of these clinical trials, is that the MSCs are coming from different places, but having the same clinical outcomes. That's what makes the functioning of an MSC at a particular site is controlled by the site, not by the origin of the MSC. So that's a fact that...
So why are there different MSCs?
Pardon?
Why are there different kinds of MSCs?
Because all these MSCs come from pericytes, all come from pericytes, right? So if you have a blood vessel and you have a pericyte, this part of the pericyte has its back to that tissue. So if it's liver versus brain, its microenvironment is hugely different, so therefore its chemistry is different. So the innate chemistry is different. The response characteristics of these cells, not so different. So we're trying to work out the molecular biology of that, not so...
Are you going to be able to do that whole bone trajectory?
Not me personally, but long after I'm dead, somebody's going to be able to go through all of that and figure out all of the response profiles.
Do you have to add signaling molecules to make them do things?
Again, the clinical fact, so I can't tell you the molecular aspects. I can only tell you clinical outcomes. That in acute myocardial infarcts, there's a group that have been exposed to marrow-derived MSCs. All of this is allogeneic. All of this is allogeneic. So I could take your MSCs from marrow, put it in culture, put it into my bloodstream. Of course, I would tingle with the thrill of having your cells in my body, but the curtain that they makes them invisible to my immune system. So I could take your MSCs a week later and give them a second shot, or a week after that a third shot. You would say my arm would have fallen off by that time from the rejection. Doesn't happen. And in my lab, we use human marrow-derived MSCs in mouse models of disease because the curtain from the human cells works in mouse. So again, this curtain of molecules that controls the immune system, which is dependent on the site where the cells reside, the immune response, because you had all these curtains going at the site of implantation. So again, that's a retrospective explanation. The chemistry of that we're only now starting to get at.